Welcome to Level 2. In this module, we move from General Controls fundamentals into the Prolon product offer itself. The purpose of this presentation is to give you a structured way to understand the portfolio, explain it clearly, and connect it to real HVAC applications. We will begin by showing you how the offer should be categorized. Then we will review each category in detail and look at representative examples that show how the categories come together in real projects. The goal is not just to know what products exist, but to understand how to position and apply them correctly. This version of Level 2 is organized as a portfolio deep dive first, followed by application examples. The purpose is to make the Prolon offer easier to explain, easier to remember, and easier to apply in front of contractors, engineers, and building owners. We will begin with the portfolio structure, then move into the 5-category deep dives, and finally review representative applications such as constant volume packaged units, VRF-connected jobs, chilled water systems with air handlers, and concealed water source heat pump loops. The key message is that we should categorize the offer first, explain each category clearly, and then apply the portfolio to real HVAC systems. The Prolon offer is easier to understand when it is divided into 5 categories. First, application-specific controllers, which are the core controllers for equipment such as rooftop units, air handlers, heat pumps, fan coils, unit ventilators, makeup air units, and humidity applications. Second, plant and hydronic controllers, which include controllers for chillers, boilers, water loops, hydronic coordination, and flexible I/O inputs and outputs. Third, zone and local interfaces, which include zone dampers, thermostats, communicating wall sensors, and analog wall sensors. Fourth, sensors and field inputs, which provide the measured values and proof points the controllers depend on, such as temperature, relative humidity, pressure, CO2, and current switches. Fifth, deployment, connectivity, and accessories, which support installation, startup, integration, and service through panels, focus tools, backnet bridge options, adapters, and accessories. This slide should be used as the reference map for the rest of the deck. We begin with the most visible category in the Prolon portfolio: application-specific controllers. These are controllers selected according to the HVAC equipment type and the sequence required. This category includes RTU and AHU controllers, heat pump controllers, fan coil controllers, unit ventilator controllers, makeup air controllers, and humidity controllers. Each family is designed around a specific application, rather than being presented as a generic controller with a random set of points. That is one of the most important ideas in the Prolon offer. The value is not only in the hardware, it is also in the fact that the control logic is already aligned with the type of equipment being served. These controllers are generally part of a 24-volt AC control environment and may use RS-485 network communications, Modbus RTU, or BACnet MS-TP on supported Prolon families. Field I/O may include 10K3 thermistor inputs, dry contact digital inputs, analog voltage inputs, 0 to 10 volts DC analog outputs, and digital outputs as 24 volts AC, or dry contact. The important point is that each controller should be explained through the equipment it serves, the sequence it runs, and the signals it uses. This slide shows how application-specific controllers should be explained in practical terms. On the left, the constant volume packaged unit is the main example. The wall sensor reads the room demand, the RTU controller interprets that demand, and the controller then commands the supply fan, cooling stages, and economizer as required to maintain comfort. This is a simple and strong example because the control path is easy to visualize. On the right, the same category is extended to other airside and terminal applications. Heat pump and water source. Heat pump controllers manage compressor, fan, and reversing valve logic. Fan coil and unit ventilator controllers support zone-level comfort using fan, valve, occupancy, and related logic. Makeup air and humidity controllers focus on discharge air conditions or relative humidity with the required interlocks and safeties. The message is that the same product category can serve different equipment, but the sequence and controlled medium define the application. The second category moves from unitary equipment into plant-side and hydronic applications. Here we are talking about chiller controllers, boiler controllers, water loop controllers, hydronic controllers, flexible I/O controllers, and network or plant logic tools. These products are used where the job is not only to control a single airside unit, but also to maintain loop conditions, coordinate pumps, manage lead-lag logic, or support central equipment operation. This category is especially important in systems where water temperature, loop stability, and plant coordination affect the terminal units and the overall system performance. Plant and hydronic controllers commonly operate in a 24-volt AC control environment with RS-485 networking. Depending on the supported hardware family, communications may include Modbus RTU or BACnet MS TP. Field signals typically include temperature sensing, proof switches, pressure or other analog inputs, 0 to 10 volts, DC modulation outputs, and digital enables for pumps, valves, alarms, and interlocks. This category should be explained as plant logic combined with the field signals and communication requirements needed to make the logic reliable. This slide shows two clear plant-side applications. The first example is a chilled water plant feeding air handling units. In that case, Prolon logic can help maintain chilled water conditions, coordinate pumping, and translate waterside capacity into airside comfort. The second example is a water source heat pump loop with a cooling tower and boiler. Here, the water loop controller helps maintain the common loop temperature band and coordinates the cooling tower or boiler response as required. This type of application also depends on shared infrastructure, such as pumps, proof signals, temperatures, and digital enables. The value of this category comes from coordination. Plant-side Prolon products are strongest when shared water conditions must be maintained across many devices, so the downstream equipment can operate correctly. The third category covers the products that sit closer to the occupied space or local zone. This includes zone damper controllers, thermostats, communicating wall sensors, analog wall sensors, and other local interface elements. These products connect the central control logic to room comfort, zone demand, and occupant interaction. Zone damper controllers support zone-by-zone air balancing and local response. Thermostats provide a simple local user interface for set point entry, mode selection, and occupancy control. Communicating wall sensors provide room sensing plus communication with supported controllers. Analog wall sensors provide a simpler temperature or room condition input, which is useful in standard or retrofit applications. The technical interface matters. Communicating sensors use the supported Prolon digital sensor controller communication link, while analog devices provide temperature or set point inputs. Zone damper applications may use 0 to 10 volts, DC analog outputs, plus 24 volts, AC or dry contact digital outputs. This category should not be explained only by what is installed on the wall. It should also be explained by how the local device exchanges information with the controller. This slide uses a zoned office example to show how local interfaces support broader system performance. A packaged unit serves multiple zones, while local wall sensors and zone dampers allow the system to respond to individual zone demand without losing central equipment coordination. Wall sensors provide the room-level feedback, zone controllers interpret the local requirement, and dampers adjust airflow to each zone. The same concept also applies to terminal unit room control, where thermostats and wall sensors support fan coils, heat pumps, and unit ventilators. These local interfaces also support occupant interaction through set point trim, occupancy override, and feedback. They can also be valuable during troubleshooting because they help show what the room is asking for. The key message is that zone and local interfaces make the broader control strategy responsive to actual room conditions. The fourth category is the sensing and field input layer. This category includes temperature sensors, combined temperature and humidity sensors, humidity transmitters, pressure devices, CO2 sensors, and current switches. These products tell the controller what is happening in the field. Some provide continuous measurement, such as temperature, humidity, pressure, or CO2. Others provide proof or status, such as current switches used to confirm that a fan, pump, or compressor is actually running. This category is critical because control quality depends directly on input quality. Temperature sensors are commonly read as 10K3 thermistors. Universal analog inputs can accept signal ranges such as 0 to 5 volts, DC, 1 to 5 volts DC, 0.5 to 4.5 volts DC, and 0 to 10 volts DC on supported controllers. Dry contacts are used for status and safeties. Split-core current switches can provide self-powered proof with an adjustable trip range and normally open digital output. Pressure, CO2, and RH devices are typically handled as scaled analog inputs. The key point is that understanding the signal type is just as important as understanding the variable being measured. This slide shows how the sensor layer surrounds a real RTU or AHU. Outdoor air temperature, space humidity, duct pressure, CO2, discharge air temperature, and current switches all feed the controller. The controller then uses these values to decide how to operate the unit. Temperature and RH inputs support comfort control, discharge protection, and humidity strategy. Pressure and CO2 support airflow management, static pressure, ventilation, and IAQ strategy. Current and proof inputs confirm that commanded equipment is actually running, which makes safeties and interlocks meaningful. These examples also connect back to signal formats. The controller must not only receive the correct information conceptually, it must also receive the correct signal type, range, scaling, and wiring reference. Good control depends on both. The fifth category covers the tools and supporting hardware that make Prolon easier to install, configure, integrate, and service. It includes pre-built control panels, air makeup panels, Focus software, Focus mobile applications, the BACnet equipment bridge, adapters, and accessories such as TreeCom, Bluetooth adapters, dampers, and VAV accessories. These products do not replace the controllers or sensors. Instead, they make the total solution more practical in the field. This category supports cleaner installations, faster startup, better diagnostics, and improved system visibility. Focus can connect locally through USB or Bluetooth adapters to the Prolon RS485 bus. The BACnet equipment bridge links Prolon's native Modbus network to BACnet-connected equipment. Depending on the setup, supported communication parameters may include BACnet MAC, addressing plus baud rate, parity, and stop bit matching. The main idea is that deployment is not limited to physical hardware. It also includes how technicians connect, configure, commission, troubleshoot, and expose the system to other building-level control layers. This slide explains the deployment and connectivity layer through a real project workflow. The project may begin with panelized controls, then proceed through field wiring, setup with focus or mobile tools, and finally visibility through the backnet bridge to the BAS or operator interface. Panels make installation cleaner and more repeatable. Focus tools and adapters shorten startup and service time. Integration tools help operators and BAS users see what the Prolon system is doing. This is important because a control project is not only about selecting the correct controller. It is also about how the solution will be installed, commissioned, monitored, and supported over time. This is where the deployment and connectivity category adds practical value. Now we move into the representative application examples. The first example is a constant volume packaged unit, which is one of the clearest and strongest applications for the Prolon portfolio. In this application, the typical Prolon package includes an RTU controller, a wall sensor or thermostat, outdoor and discharge air sensors, a current switch for fan-proof, and optional focus tools. The control path is straightforward. The wall sensor provides room demand, the RTU controller makes the control decision, and the outputs command the supply fan, cooling stages, and economizer. This example is a strong entry point because it is common, easy to visualize, and clearly demonstrates how the controller, sensing layer, and startup tools work together. This example requires more careful positioning. In VRF-connected jobs, Prolon is best positioned as the supporting integration and coordination layer around the OEM system. Prolon is not typically the core controller of the VRF refrigerant system itself. That remains with the VRF manufacturer. Prolon can add value through the backnet equipment bridge, flexible I/O, or supporting control logic, room sensing, ancillary equipment coordination, and focus tools for setup and visibility. This can be especially useful when the project requires visibility, local sensing, ventilation coordination, makeup air coordination, or integration with a broader BAS. The important message is that Prolon improves visibility, coordination, and support around the VRF application, while the VRF manufacturer remains responsible for the core refrigeration logic. This example brings together plant-side and air-side control. A chilled water system produces and circulates chilled water, and the air handlers then use that chilled water to satisfy space loads. In this type of application, a Prolon package may include a chiller controller, hydronics or plant-side logic, the AHU air-side control layer, temperature, pressure, and proof sensing, and optional bridge or focus tools. The value is in coordination. The plant creates stable chilled water conditions, while the AHU side logic translates that capacity into air-side comfort. When the plant side and air-side logic work together under a consistent control philosophy, the system becomes easier to understand, easier to troubleshoot, and easier to commission. This example shows a broader distributed application. Each concealed water source heat pump serves a local zone, but all of the units share a common water loop supported by pumps, a cooling tower, and a boiler. In this type of application, a Prolon package may include heat pump controllers at each unit, a water loop or hydronics controller, a boiler controller, tower and pump proofing, temperature sensing, and optional BAS visibility tools. Prolon can support both the local comfort layer and the shared loop logic. The local heat pump controllers manage zone comfort, while the water loop logic maintains the common loop within the desired temperature range. This is a strong example of how the Prolon portfolio can scale from room-level comfort to shared infrastructure coordination. To close the technical content, return to the central logic of the deck. The Prolon offer becomes much easier to understand and present when it is organized using an application-first, category-based structure. The products were divided into 5 categories: application-specific controllers, plant and hydronic controllers, zone and local interfaces, sensors and field inputs, and deployment, connectivity, and accessories. Each category was described based on product types, capabilities, signals, benefits, and applications. The category slides set the foundation, and the representative examples show how the categories come together in real jobs. The method is simple. Begin with the application, identify the controller category, add the correct local interfaces, add the sensing layer, and complete the solution with deployment and connectivity tools. When the portfolio is explained this way, it becomes easier to sell, apply, install, and commission. Thank you for joining this Level 2 session. We appreciate the time you've taken, and we hope the module gave you a practical way to understand and explain the Prolon portfolio. Remember, Prolon should not be presented as just a list of products. It should be shown as an integrated system solution. And as we close, we invite your questions on project types, equipment applications, controller selection, sensing requirements, backnet, integration, or how to position Prolon with contractors, engineers, and building owners.